decimal equation. So when solving equations with decimals, we're going to use the same process to get the variable by itself. So just numbers, but now they're numbers with decimals. And then remember, you can always use a calculator to solve these problems. So let's go over the first example. Example 1, the temperature in town A is 10.5 degrees and falling 2.2 degrees every hour. So the temperature in town B is 4 degrees and rising 3.5 degrees every hour. So what hour will town A and town B have the same temperature? We're going to solve for age in the equation below. So we have our equation set up. We're just going to go ahead and solve like we have before. So the first thing we're going to do is either move one of the ages by adding or subtracting to both sides. So because this one's negative, I'm going to go ahead and add 2.2 on both sides. So notice, same process, right? We got this to 0 on the left-hand side. So that way the h then is just on the right-hand side. So we just wanted to make sure it was moved to one side of the equal sign. So 3.5 plus 2.2, well, that would be 5.7 h, right? And then we just go plus 4. Then we can just go ahead and bring this 10.5 down. 0 plus 10.5 is just 10.5. And then our next step would be to continue to get h by itself down. So we got it onto just one side, so the variable is just on the one side. So that was a good first step. And then we're going to go ahead and subtract 4 on both sides. This becomes 0. We bring down 5.7 h. And then we have 10.5 minus 4, so that's 6.5 down. Just make a bigger equal sign. And then this final step is to h by itself, because we're left with just 6.5 is equal to 5.7 h. And we want to find out what h is. So 5.7 times what number is equal to 6.5? We can just remember. So now we can go ahead and go 5.7 divide, right, on both sides, divide by that. So let's get our calculators out. 6.5 divided by 5.7, and we get 1.14. We'll just leave it the nearest hundred. So h is equal to 1.14. So that's how long it would take until the temperatures are the same in both towns. So let's do the last example. So example 2, we're going to use the equation below to solve for x. So notice we have, right, decimals. We also have distributive property in this one. So let's just rewrite this first. So our first step is to distribute this 2 across. So 2 times 4.95. Well, that's 9.9. Now 2 times negative 2, well, that's just, right, or minus 2. So you now have just minus 4, which is equal to 3.5x plus 4. And notice how I forgot the x right here. So let's go back. So now we have 9.9x minus 4 is equal to 3.5x plus 4. So let's get the x's to just one side. So we're going to do that, and I'm going to go ahead and subtract 3.5x on both sides. This becomes 0. So we're left with just 4 on the right-hand side. We have this minus 4 we can bring down, and now we have 9.9 minus 3.5. Right, well, 0.9 minus 0.5, right, that's 0.4, 9 minus 3, that's 6. Now, if you aren't sure, right, we could just go minus 3.5, and we get 6.4. So now we have 6.4 minus 4 is equal to 4. So let's also continue to notice that I keep forgetting the x here. So we just make sure we just bring that down. So now we have 6.4x minus 4 is equal to 0 plus 4. So let's go ahead and add 4 to both sides. This way, x becomes more on its own, right? We're getting closer. So that just becomes 0. So let's just bring down 6.4x equals 4 plus 4. That's 8. Now, to get x by itself, we have to undo this multiplication, and we just go ahead and divide. Right, that becomes 1. So we're left with just really x. Now we have 8 divided by 6.4. We get 1.25. And that would be our solution.